Lesson 1.4 is Identity and Equality Properties. The purpose of the identity and equality properties and what we're trying to do in this section is to be able to recognize those properties and then to be able to use them when solving a problem. It basically will help you when you're trying to solve something to be able to, use these properties with the equations that you're working with. The additive identity property says that the sum of any number and 0 is equal to the number. So 0 is then called the additive identity. So for instance, the sum of any number, and we could literally pick any number, and 0 is itself. Okay, that's an example of the additive identity property. We could generalize it with variables and say that a plus 0 is equal to a. So 0 is called the additive identity. Two numbers with a sum of 0 are called additive inverses. For example, 5 plus negative 5 is equal to 0. So any number and it's negative, if you add them together, equals 0. So 5 and negative 5 are additive inverses. A plus negative a are additive inverses. Any number and its opposite would be additive inverses. The multiplicative identity property is very similar. It says that the product of any number and 1 is equal to the number. So therefore 1 is called the multiplicative identity. An example of this would simply be to take any number, we'll represent it by a, and if you multiply it by 1, you get a. Okay? If you have 5 times 1, it's 5. Okay? So any number times 1 is equal to that number. The multiplicative property of 0 says that for any number a, the product of a and 0 is 0. So that's simply saying that any number we pick times 0 is equal to 0. The multiplicative inverse property says that two numbers whose product is 1 are called multiplicative inverses. For any number a over b, where a and b are not equal to 0, there is exactly one number, b over a, such that if you take a over b and multiply it by b over a, you will get 1. The reflexive property says that any quantity is equal to itself. So a is equal to a, 7 is equal to 7, 4 is equal to 4. Pretty logical. The symmetric property says that if one quantity equals a second quantity, then the second quantity equals the first. So when we think about a line of symmetry in math or in science, we're saying kind of like a mirror image. So if we think of it that way, a is equal to b is the same thing as b is equal to a. I'll put an if there in front and fix that. Okay, the transitive property states that if one quantity equals a second quantity and the second quantity equals a third quantity, then the first quantity equals the third quantity. So what we're saying there is if a is equal to b and b is equal to c, then a must be equal to c. So that's the transitive property. An example of that with numbers might be if 3 plus 4 is equal to 7, and 7 is equal to 5 plus 2, then 3 plus 4 must equal 5 plus 2. That's the transitive property. The last property is the substitution property, which states that a quantity may be substituted for its equal in any expression. So what it's saying is if a is equal to b, then in any expression, A may replace B.
I feel like other countries hate us. Their only goal is to beat us.
An example of that would be if x is equal to 3, then 3x would be the same thing as 3 times 3, because I can then substitute 3 for x since x is equal to 3. Okay, so now that we've seen all that, the question is what are you going to be asked to do with this? So some problems will be something of this nature, where it'll be n times 12 is equal to 0, and you would say, of course, well, that must mean that n is equal to 0, and what property is being used in order to figure that out? Well, that would be the multiplicative property of 0. And I'm going to do some abbreviating here. Multiplicative property of 0. Okay, so another example. What if we have n times 1/5 is equal to 1? What must n be? Well, if we think about it, the multiplicative inverse property would apply here, and what the multiplicative inverse property would say is, well, n must be equal to 5 over 1. And the reason for that is because 5 over 1 times 1 over 5 would equal to 1. And we could cancel out the things that, the numbers and prove that. So let's cancel the 5's here, and all we're left is 1 over 1, which is equal to 1. Okay, so now we're going to see an example of one of the more complicated types of problems that you'll be asked to do. And in this particular example, what we're going to do is we're just going to simply evaluate the expression, so simplify it. And in each step that we do, we're going to name the property that we used in that step. So the first thing I would do is we remember order of operations tells us to work inside the parentheses. So we'll do that. We're going to have 1/4, and then 12 minus 8 is 4. So that's substitution. We substituted 4 for 12 minus 8. So off to the side here, we're just going to write substitution for that step. Didn't leave myself quite enough room there. Then we're going to also do the same thing. We're going to do some substitution inside the second set of parentheses. So 15 divided by 5 is 3. 3 minus 2 is 1. So we're substituting 1 for what's inside the parentheses. The next step, we would do 1/4 times 4, and we would get 1. And the property that we're using there is the multiplicative identity property. Or excuse me, the multiplicative inverse property. It's multiplicative inverse because 1/4 and 4 over 1 are multiplicative inverses, and if we multiply multiplicative inverses together, we get 1. Next thing we would do is, when we drop to the next line, we're going to do 3 times 1 and get 3. That's an example of the multiplicative identity property. Okay, and then lastly, 1 plus 3 is 4. That's an example of substitution. Okay, so that's basically how these will work. You're just going to go ahead and work out the problem as you normally would with the correct order of operations. And then in each step, you're going to say what property you used in every step. If you can't come up with a specific one, such as multiplicative identity or multiplicative inverse or additive inverse, then more than likely it's going to be substitution. So this is what we will practice tomorrow.